So let's try to find the relationship between apparent and true prevalence. We'll start by finding out the probabilities corresponding to each of the cell values A, B, C, and D. Let's start with A. We have seen that true prevalence is A and C divided by A, B, C, and D. Let's call it again M. And that the sensitivity of the test is A divided by A and C. If we get the product of these two, A and C is a common term that cancels out, and this is all equal to n. So the proportion for the first cell is going to be the product of sensitivity and true prevalence. Let's go now to cell C. C divided by A and C is the false negative proportion, which is equal to 1 minus sensitivity. Now if we get the product of 1 minus sensitivity and true prevalence, again A and C is a common term that cancels out. So the proportion corresponding to this cell is the product of 1 minus sensitivity with true prevalence. We will go now to the column for the healthy individuals. The proportion of healthy individuals is B and D divided by A, B, C, and D. Okay, so this is equal to 1 minus true prevalence, of course. And the specificity of the test, as you may recall, is D divided by D and D. So if we get the product of these two, here B and D is the common term that cancels out. So the proportion corresponding to cell value D is the product of specificity with 1 minus true prevalence. Finally, for cell B, the proportion of false positive results is B divided by B and D. So this is equal to 1 minus specificity. Now if we get the product of 1 minus specificity with 1 minus true prevalence, B and D is a common term that cancels out, right? Okay, this is equal to M again here. Okay. So the proportion corresponding to cell B would be the product of 1 minus specificity with 1 minus true prevalence. Now that we have the proportions for each cell, let's see if we can define apparent prevalence as a function of them. Apparent prevalence is the proportion of individuals that test positive. So this is apparent prevalence. And it's going to be the sum of this term with this term. If we solve for true prevalence, we get this equation, which has been first described by Rogan and Glanden back in 1978. So true prevalence can be expressed as a function of the apparent prevalence and the sensitivity and the specificity of the diagnostic test. Despite the fact that this formula has been around for so many years, the majority of prevalence studies do not use it, and they just report apparent prevalence estimates without adjusting for the sensitivity and the specificity of the imperfect diagnostic process.